Hello, and welcome to the Chip Observer, the podcast where we look beyond buzzwords and try to navigate the ins and the outs of the semiconductor industry and explore how technology is evolving and transforming our daily lives. Presented by TechInsights, the definitive source of semiconductor analysis. And as always, to get the most out of this podcast, we suggest you subscribe and follow. Today, we're diving into a critical, timely, and maybe even existential question for the tech world. Is artificial intelligence at war with sustainability? Now, I know that's a bold framing, but stick with me. Sustainability is defined as the practice of maintaining processes or systems in ways that avoid the depletion of natural resources, ensuring long-term ecological balance, supports economic viability, and promotes a social well-being. And while AI is reshaping everything from healthcare diagnostics and creative tools to climate modeling and chip design, it's also devouring energy, accelerating demand for raw materials and pushing infrastructure to its limits. As the AI revolution marches forward, there's a growing concern that the very tech reshaping our future could also be accelerating our destruction. Let's put this into some context. Every ChatGPT query you make uses up to 10 times the energy of a standard Google search. And the training of large AI models uses astronomical amounts of energy. We're talking about enough electricity to power the typical US home for over a century. But before we all panic, I should stress it's not all doom and gloom. It's still not perfect though. So what's really happening here? Is AI really at war with sustainability? That's the question we put to our guest, Stephen Russell, a senior technical fellow at TechInsights, an expert in sustainable semiconductor manufacturing and AI systems. So welcome back, Stephen. Thank you.
Thanks so much. It's a pleasure to be here.
How about we start by looking at bridging gaps between the promises and the practices? The energy used for AI data centers is now being compared to that of the use of entire neighborhoods. We're seeing reports that say single AI servers can consume as much power as 10 homes, with industry-wide use possibly rivaling close to a fifth of all US households. That's a voracious consumption of energy and hardware used. How is big tech keeping their promises about going green beyond just buying offsets, for example?
Sure. I think keeping those promises is very difficult. A lot of big tech companies have net zero goals for the year 2030. Yet last year, we saw significant increases, particularly those who have a big presence in AI. We saw huge increases in emissions year on year. And this is mainly driven by the AI use, their scope 3 emissions. And it's a big challenge. And of course, offsets are controversial.
Yes. They let companies counter carbon emissions by funding climate projects such as reforestations or clean energy. They offer a quick way to take climate action, but critics warn they can act as a loophole, delaying real change. There are, however, still both practical and technological areas which can improve things.
Before I dive into those, it's important to set even more context for what we're facing. So first of all, when we talk about sustainability, people's minds immediately go straight to emissions. And of course, that's important. But also sustainability refers to practicality. Is this sustainable from, say, an infrastructure perspective? Can this even be done at the rate it's growing?
This is not just about emissions.
But it's about, can we practically even do this? And then touching on what you said as well about AI servers, they are power hungry. Earlier models would use maybe between 1 and 2 kilowatts, which is comparable to the power usage of a small household. Modern ones, based on NVIDIA's new Blackwell architecture, for example, might use over 10 kilowatts. So we're talking 10 homes or a busy commercial kitchen.
Right.
In one of these data centers, there could be hundreds of thousands of these servers to get you up to that 2.2 gigawatts. Cooling these things is important, and cooling is water intensive. So in these servers we're talking about as well, beyond the power, you could have up to 10 million liters per year. It's a huge amount of power and energy demand.
It's important we should mention that smarter cooling is becoming a key part of reducing AI's power footprint. It's not just about the chips. Full data center efficiency, including liquid cooling and lifecycle emissions, matter. Training large AI models like GPT-3 comes with major energy demands, both promising and problematic for sustainability. While exact figures aren't public, estimates suggest significant GPU use and emissions. It highlights the need for more transparency and efficiency in AI development.
So GPT-3, trained in 2020, used 10,000 of the latest generation of GPUs at that time. That's estimated to be 500 tons of CO2e, again, in terms of that CO2 equivalent, based on some work done by the University of California at Berkeley. You're looking at about 3 round trips, flights from San Francisco to New York. Now, parallelization is key. While it would take about 350 years on one GPU, technological advancements mean to do this on the next generation of GPU, you go from 10,000 GPUs taking about a month to 1,000 GPUs taking about a month. So they are becoming more and more efficient. This brings us to a strange kind of paradox, actually originated during the Industrial Revolution.
There's a paradox that was coined by a British economist, the Jevons paradox. It observed that coal use during the Industrial Revolution became more efficient. All that led to was an increase in coal consumption, not a decrease. We're seeing the same thing occurring here. As this growth continues, then there's just more and more demand.
And it's like, you can compare this to, say, buying a more fuel-efficient car. You spend less on gas. But then what do you tend to do? You tend to use your car more. And then you just end up burning more fuel with your fuel-efficient car.
And of course, this is directly affecting the upgrade cycles. AI hardware is evolving so rapidly. That kind of constant upgrade creates significant waste and emissions from both manufacturing hardware to the increasing amount of energy used in training them. Many can see it's a constant churn contributing to the unsustainable hardware waste.
Of course. I want to stress as well, it's very easy to, when we get into these conversations, to be doom and gloom and, oh, this is terrible and look at all the emissions. But I am at heart a technologist. I do believe technology has the solutions. It's what we do. And another thing that may get thrown around is, when we talk about these kind of things, why pick on AI? And it's true. It's still a fraction of global emissions compared to, say, aviation or...
It is a hot button topic.
For sure. And I feel, even though it's the industry I work in, I feel it's fair. The reason for that is our industry is full of some of the smartest people on the planet. If anyone can solve these problems, it's almost incumbent on us to be solving these issues.
The same people building GPUs feel responsible for helping solve the challenges their creations bring. While the energy demand for AI continues to grow, the solutions are already forming. Smarter hardware, and even optical connections that cut both power use and latency. The challenge isn't just technical. It's about willpower, policy, and pressure. The tools are here. Now it's about whether we choose to use them. There's a classic phrase in real estate: location, location, location. It still seems to ring true in the tech industry. Site selection for things like fabs and data centers, sustainability often takes a backseat to geopolitical and economic factors. That can mean choosing locations with dirty power grids or water-stressed regions like parts of Arizona. How do we start getting green metrics like grid cleanliness or water usage to carry equal weight in those decisions?
A very important point. And I think this is a good opportunity to discuss. So we've talked a little bit already about the data centers and their operation themselves. About this touches on a real challenge in terms of where and how the chips are made. So while the emissions for chip manufacture aren't as much as the emissions for chip usage in terms of AI, they're not insignificant. And we really dive into this in TechInsights and our data. We've made various forecasts on this, and we have a first of its kind model, the manufacturing carbon model, which can plot out the emissions step by step for each of these processes. It can factor in location, scope 1, 2, and 3 emissions, water usage, the whole manufacturing process. Our data shows that total manufacturing emissions could approach 20 million metric tons by the end of the decade for these AI chips alone. And the semiconductor industry as a whole is approaching 300 million. So it's not insignificant.
especially with production concentrated in places like Taiwan, Korea, and the US, given that grid carbon intensity can vary up to fivefold depending on the region. And with Taiwan facing real challenges accessing renewable energy, how much of a role do you think geography should play in shaping a more sustainable semiconductor supply chain?
Taiwan, for example, where it's no secret that the most advanced AI chips are currently made, has real challenges in terms of actually getting renewable energy. It's an island nation. They rely heavily on energy imports, and there's real challenges to be able to, again, practicality to actually be able to improve that grid. Whereas other regions, like you suggest, Arizona, has water issues. I feel there is progress being made, so technologically, the very latest fabs are now very good at water recycling and reuse. So that's a positive. In terms of where these chips are made, it's going to be interesting. For example, Arizona does have a much lower grid carbon intensity than, say, Taiwan. Now, I think it's naive to think that they're doing this because it's more sustainable. I think there's obviously economic and even geopolitical factors at play. But it's an interesting choice if you've got a choice in the future to make a chip in a fab which is 5 times the grid's carbon intensity. That can certainly play a role.
I came across some interesting insights recently about how certain fab manufacturers are exploring colder climates to help reduce the energy needs for cooling. I'm curious to see, could leveraging these environments meaningfully cut down on water use and energy use for a cooling system?
Yeah, it's an interesting point for sure. There's absolutely a lot of positives to Canada. In terms of the grid carbon intensity, it's fantastic, especially in Quebec, for example. There's a lot of renewable energy and the temperature is appealing. I think there's a few challenges. So again, it's having the political will and drive and business economic factors to convince to build in these regions. There are also interesting factors at play in terms of, like, why do people keep picking Arizona in the States, for example? Why not another region of the United States? Well, something that's important in fab design is moisture and humidity. That plays a huge role. And also, even believe it or not, regions that are stable, say from a tectonic perspective, tectonic plates. So that's why maybe, building in California isn't the greatest idea, for example.
There's no denying that location will always play an important role in where these fabs or data centers end up being built. And it may be difficult to convince companies to build them in colder climate. Many do believe that it's something countries, like Canada, should be pursuing. Another major challenge right now is the lack of global standards for reporting emissions. Without consistent benchmarks, it's easy to spin the numbers, especially with things like offsets. But as AI continues to evolve, there's growing momentum for industry groups, nonprofit organizations, and public pressure to push for greater transparency and accountability.
Say the example, the carbon neutrality of Apple Watch, which again may be controversial in terms of offsets, but why are they doing this? Because it's important. People care about this kind of thing.
That's right. Public opinion is a powerful force in shaping how companies approach AI and sustainability. As awareness grows, so does the demand for transparency, ethical practices, and greener technologies. AI is incredibly energy intensive. Yet at the same time, it's driving major gains in decarbonization, logistics, and overall efficiency. So while it's part of the problem, it also holds potential as part of the solution. In your view, where is AI currently making the most meaningful, positive impact? And is it enough to outweigh its own footprint right now?
Yeah, for sure. I think that's not far away, and it's already happening in pockets. So places where AI can help. Advanced AI models can forecast things like solar and wind energy outputs depending on the weather, helping utilities balance supply and demand more efficiently. And broader, machine learning can improve grid stability and reduce reliance on fossil fuel backups in general. But there's many other ways as well. It's almost endless, and it's difficult at this point to see which is going to have the biggest impact, but we can have some reasonable estimates. So I think the idea of smart grids and energy optimization is likely to have the biggest impact. But then you can go beyond and say things like optimization of delivery routes, reducing fuel consumption, or in aviation and shipping, AI systems managing heating, cooling, lighting in smart buildings. dynamic energy pricing, even to the point of manufacturing of semiconductors.
AI can help with discovery of alternative materials to be used in the process. The list is endless, but it's also difficult to see. It comes back to the optimism of it all.
You said towards the start of this, AI could end up using as much as power as a fifth of all US homes. Well, you'll see forecasts and predictions from AI advocates like Sam Altman, for example, or Bill Gates, who say, well, it could actually save that much, if not more. So it offers so much promise, and it's up to us as technologists, media, NGOs, general public, and so forth, to ensure that this AI transition is sustainable and held accountable. It's not a bad thing per se, but it's how we pursue it and implement it that we just need to be aware of.
Like any good investment, we need to nurture it. We'll get back more than what we put in. It's very possible we'll need to use some resources now so that down the line we're able to renew them and use much less in the process.
Absolutely. And, we go back in terms of, again, I caveat with I'm biased because I believe in technology, but if you go back to, say, the days of the Industrial Revolution, what was the alternative? We don't do it? I can't think of really any example in human history where we've really seen a technology and everyone's just been like, nope, we're not going to do that. We'll leave it. It's like it or not, it's happening. So I think, again, we have to use best practice, use pressure where it's needed, and pursue this in the right way and the best way possible.
What about more radical technical leaps? I'm talking about things like neuromorphic computing.
It's tricky. There's a lot of advocates for it. And there's the idea that the human brain consumes about 20 watts of power, whereas the latest generation of AI GPUs, about a kilowatt each.
Instead of using traditional binary logic, it uses brain-inspired systems with artificial neurons and synapses to perform tasks more efficiently. And this model can drastically reduce power consumption, making it a promising solution for a sustainable AI.
And AI is making some significant progress. I think it's still fair to say that the human brain is better.
With all that said, what will truly drive a shift towards sustainable AI? Is it going to be consumer demand? Is it going to be regulatory changes? What's your opinion?
I think a bit of everything that we've discussed. I think there's technological improvements. I think governments do have a role to play, and despite fractured political positions globally, I do think there is significant progress being made, particularly regions such as the EU are really making good progress on this. Public pressure, media pressure, there's all a role to play. I think in terms of technology, we're really just starting to find out about the emissions consumed in chip manufacture and putting together the picture. And I believe, again, being biased, but I believe this is where somebody like TechInsights can have a huge role to play.
So what did we learn today? Well, AI is undeniably powerful, but that power comes at a cost. Training large models consume enormous amounts of energy, sometimes more than entire neighborhoods, and generates substantial emissions. But AI isn't just part of the problem, it's also part of the solution. We explored how smarter cooling, better chip design can help reduce AI's environmental footprint. We also heard how public pressure, transparent reporting, and even choosing the right location with cleaner grids or colder climates can all play a role in sustainable decision making. There's a paradox at play here. As AI gets more efficient, demand grows even faster, but that doesn't mean we give up. The path forward is full of promise. Ultimately, whether AI helps or harms the planet may come down to the choices we make today, not just as technologists, but as policymakers, businesses, and consumers. The tools are here. Now it's about whether we choose to use them wisely. A special thank you to Stephen Russell for sharing his notes and insights. There wouldn't be much of a story to tell without his industry knowledge and passion. Note that the contents discussed here today were for informational purposes only and don't reflect views or opinions of the institutions or organizations mentioned. As always, to get the most out of this podcast, please subscribe and follow to get the latest news and updates. And for more semiconductor details with a snapshot on the industry, we invite you to visit us online at techinsights.com and sign up for free to become a guest user. There you'll gain access to our platform with complimentary reports, analysis, specialists, and industry-related news. We'll catch you next time with more observations and insights, where every listen brings us closer to the stories that matter. Until then, stay curious, stay connected, and stay insightful.